everyone, so this is very exciting. I've been working on this a little bit, and what I've done is I've swapped out my old 2212 motor for a 2312 motor from a Phantom 3, and the results for amp draw and flight time are much better than they were. So besides the eCalc program that I've been using, I've also learned how to do these really simple calculations that relate the battery capacity to the amount of amp draw, and I mean it's way simple, and it's actually not hard to do at all. All you have to do is you have to have one of these amp measuring devices. So you use the top amp draw right there, and then you look at your battery and you look at what your battery is rated for. This one's rated for 3,300 milliamp hours. So that's milliamp hours, divide that by 1,000, you'll get amp hours. Amp hours is what you want to calculate your actual flight time, because then it's directly going from amps to hours. Amp hours, get it? So you divide the battery capacity by the amount of amp draw that you are at, XXX throttle value, and then you get a decimal or a fraction, and then you multiply that by 60 minutes. So I didn't include that here, I just multiplied it, equals 44 minutes, so that's roughly like 44 out of 60 as a fraction, right? So this one down here, obviously it's 3.3 divided by 3.3, that's 1, multiply 1 by 60, you get 60 minutes. So it's really simple, and it's super intuitive. All you really need is one of these. So hopefully we can get this thing to be exactly 60-minute flight time. As you can see, I got this really cool like Turniggy amp volt power indicator, and it's super nice for doing this. This is exactly what I needed. So if I raise this to half throttle here, it's gonna raise to about 3.2 amps, somewhere around there. Move the servos around, 3.3 amps or so. And then I move this to and that, I mean, I got my max amp rating to be 11.3 at some point. I don't know how, but it was around 11.3, 11.2. I'm really happy with these DJI motors. This one especially has just proven to be super efficient, even more efficient like by 1 amp or 2 amps actually, a max throttle than the 2212. And that is just phenomenal. I can't believe how far like this type of technology has come, and for how cheap it is. I mean, a new one of these is 18 bucks. I got it for free, but it was 18 bucks is barely anything. And I mean, it doesn't change the overall cost that I put in the description of my last video of this aircraft. So we'll see how this works. Next step after this is to build a new airframe, possibly with multiple motors. So I'm here now at the field, and this is going to be the version 2 flight test with this new motor. Alright, so here we are pre-flight. We have the battery at 52%, and I'm going to fly it for 5 minutes, and I'm going to see how much the battery percent drops. Lot more power than the other motor, which is awesome, because that's exactly what we need. We need more power and less amp draw, and it's already showing that. And I'm climbing. This is still half throttle, less than half throttle actually, and I'm way up there at this point. So we're gonna transmitter timer, and actually you can look at the video timer and just let me know when we hit 5 minutes. Alright. I try to move the servos as little as I can here, just to straighten them out and put them in the right direction. And it's choppy, I'm losing altitude. Climb here. A little bit more throttle. Jesus Christ. Alright, there's some smoother air. Barely. start somewhere. So when I was doing thrust testing, I was looking at the numbers as I increased the throttle, and right around half, there's a big jump in amp drop. So it's kind of exponential between lower throttle and higher throttle, which is kind of annoying, but after it gets past that point, it stays at like 11 amps until you hit full throttle. So the lower half is like has a threshold of like 3 amps, or maybe I don't know, 4 amps, and then once you get past that point, it starts going up pretty fast, but then it stops again. So it's really strange. It has this big hump of increase in throttle. Now, I don't know how I'm gonna bring this down without killing it. Let's hope I can do that. But we'll see. What's the time at?
Almost 3 minutes.
3 minutes? Okay. Crap. Let me know when it hits 5 minutes. The wind's trying to throw it over. There we go, that's a nice little stand still there. Oh jeez. Still climbing. I'm not touching the throttle right now, but it's climbing because of the wind and the thermals and whatever. It's way up there. I don't want to get it too far away. I don't know how far this receiver goes. I'm pretty sure this is one of the aftermarket ones. They're pretty reliable, actually. But I think I'm above most of the choppiness now. Oh, now I just hit it again. I went lower. Oh boy. I can't.
4 minutes.
Alright, just let me know when it hits 5, because we took a second there to launch the plane. And then I'll bring it down. I don't think I'm going to try to catch it. It's going to be too risky. There we go. That's smooth. I just don't feel like getting it that high. Battery started at 52%. That's my countdown on my transmitter. What does it say on the phone?
4:55.
What's it say?
5
5?
minutes.
Alright, write it down. Alright, so I had to go 8 seconds over so I could land it safely, but I'm going to plug in the battery checker right now and we'll check it. Alright, so here we are. We have the battery plugged in, and it says 41% coming from 52%, and so that's going to be a drain of 2.2% per minute. 2.2% is much, much better than what I got on the previous motor, the 2212, and now I have this 2312 here. And that 2212 got a 3% to 4% per minute drain. So this is definitely a large improvement. So if we use 80%, I'll be able to fly for a maximum of around 40 minutes on a day like this, and also with like 8 seconds over that 5-minute time. I also need to get out here when the air is a lot smoother and also colder, so that I can get an accurate maybe 20-minute flight time where I can more accurately perform the calculation in order to, get the best consistent field data. But good news is that this motor has more power than the other one, so it's actually got more power and more efficiency. So it's a big jump from the other motor, which is really good. Next step is to design and make a twin plane after I do further testing on this, which I will most likely release a video on, and we'll see how long we can get this battery to last. Alright, so here I am on the eCalc website, and I've input all the parameters for a 2-motor aircraft that I would be designing as my next step in this project. So because these motors are more efficient than the 2212s, these 2312s are more efficient than the 2212s, I can lower the ESC size, increasing efficiency. The model weight, I'm guessing, is going to be around maybe twice the weight of the old airframe, so I upped it to 10 ounces instead of 2 ounces, and then added to this is the weight of the entire drive. Unfortunately, eCalc does not have a 6600 milliamp hour 4-cell battery as one of their options, as I would be using by buying another 3300 milliamp hour 4-cell and aligning them in parallel or series. I forget which is which that doubles the capacity. So I'm using this one. So the flight time and the thrust to weight ratio are going to be a little bit inaccurate, but this is close enough for now. The mixed flight time is going to be 24.2 minutes. We don't have to worry about that much because it's an average of all of these flight times over here. The thrust to weight ratio is going to be much higher actually than the one from the previous setup with a single motor, and it's going to be at around 2, or maybe a little bit less than 2 once we increase the battery size. However, it's definitely going to be an improvement, and it will increase the payload capacity as well as allow us to cruise at lower throttle values, increasing the efficiency even more. As you can see down there, the highlighted throttle value at 52%. The highlighted rotor runtime is 55 minutes instead of 60 minutes. That should be bumped up with the higher capacity battery, and it should be around exactly the same as the single motor setup. However, we'll be able to cruise at a lower throttle value due to the larger thrust to weight ratio, and this new design will integrate larger airfoils that I'll be able to build that will generate more lift, and therefore I won't have to run the throttle as much, meaning that it'll be even more efficiency. So the new design will be able to cruise at a lower throttle value, more efficiency, larger payload, better plane overall, as long as I can do it right.